Hello and welcome to this live webinar with Incari, hosted by Colourdesign News. I'm the editor of CDN and my name is James McLaughlin. Now, in this webinar, the Incari team will be presenting a complete overview of Incari's HMI development platform. And from the presentation you're about to see, you'll understand how Incari can speed up the current HMI creation process due to its one-stop solution approach for the entire development pipeline. And afterwards, we're going to have a Q&A session with the team. So please drop your questions in the chat box and we're going to put them to both of the guys we've got from Incari here today. Just a little bit of housekeeping regarding IT. We encourage you to be near a wireless router, and for maximum connectivity, connect via an Ethernet cable. And if you are having issues, we suggest you follow the sort of classic piece of IT advice, and that is to log out and restart. Now, without too much ado from me, I'm going to introduce Alex Grass, CPO of Incari, and Abdallah Hubala, who's Director of Engineering, who are going to take you through the platform. Thanks very much. Enjoy.
Hello, everybody. My name is Alexander, and today I would like to introduce you Incari Studio, our HMI development platform. And so let me share my screen and start the presentation. So first of all, you guys have registered for CGI Studio presenting Incari Studio. There is some news. CGI Studio becomes Incari. So just for your information, from today on, we're going to be introduced as the Incari company developing the Incari HMI development platform. So just talking about a little bit about our company. So CGI Studio, or basically now Incari, was founded in 2011 and started as a service provider back in those days for doing rendering services in the automotive environment, doing classic marketing renderings, press campaign renderings, all that kind of stuff. Since 2015, we are developing the Incari platform, and I would like to explain you where we're coming from and what we do, and yeah, just to present to you Incari. So it all started with HMI visualizations. Since 2014, we are one of the suppliers for the Porsche AG, delivering content for their HMIs. In 2014, the new HMI system has been introduced, and we are doing the classic rendering approach. And since today, we're doing this, so this is an ongoing project. But over the years, the amount of images increased. So this is the classic rendering approach. So from this graphical perspective, it all started with 10 images. Over the years, it increased to 40 images, and right now we're talking about 60 to 80 images per car. So as you can imagine, this process is quite redundant, is quite complex, and also sort of rendering skills in order to generate those kind of high quality images for HMI renderings. So just to give you a little overview, this is how it looks like on the upper left corner. This is the rendering we do. Then on the lower left corner, it will be enriched with the HMI content, with the interactive components. And in the end, last but not least, this on the right-hand side, you see how it looks like Panamera for an HVAC control. Also, when we take a look into the complexity of the rendering, as you can see on the upper right, this on the center console, those are the renderings. Of course, it is obvious that Porsche requests also individualization for their customers. So, which means if somebody buys a blue Porsche with a red interior, it would be great if the same representation would be also displayed in the car itself, rather than having just one single color. But this leads, when we talk about the same classic rendering 2D approach, this will definitely lead to some sort of car configurator in the end, which is not really feasible for such a small embedded device integrated in a car. So we took this as a kickoff to say, okay, to think about what does it really require to generate an interactive rendering engine which is capable of presenting such high quality content, and at the same time is switched colors and configurations individually. we also took it a step further, and we thought, okay, it's not only about representing a 3D mini car in an embedded device. It's more like developing a technology which allows you to interactively display high dynamic content on any kind of screen. And when we take a look into the future, for sure, the amount of screens is getting higher, the resolution is getting higher, and even the display types we don't know yet. So you can use augmented reality for windscreen projection when we talk about autonomous level 4 driving, for example, up to holographic view. So we don't know. So what we wanted to make sure that with our technology, if we start developing it, is at least capable of driving that kind of future-proof technology. So at that stage, Incari was born. Incari is the abbreviation for the intelligent car interface. And I just would like to give you an overview about for who is Incari designed or developed. So we made our assessments, our internal assessments, and we also spoke to our customers, and we found out that that in current huge gap between two big departments who are responsible for developing such HMI systems. On the one hand, you've got the UX and UI design department, and on the other hand, you've got the electric department. And both teams need to develop one single project to be integrated in. The issue is in that process is that the two are quite distinct. So the UX design is doing their fantastic visionary UX and UI designs. The electric department needs to deal with the actual about costs and so on, and somewhere in between find the compromise, and this is how it will look like in the. So we thought from our perspective with an HMI development platform, in this case Incari, we wanted to close the gap between the engineering and that the people can work on the same platform on the same basis, on the same code basis, on the same project basis, which allows them to iteratively create much more ideas. The ideation phase, a bigger ideation phase, so even the time to final integration could be shortened. In the end, you can output Incari content to prototypes, to seating bug installations, to virtual reality installations, up to final production versions, if you like to. So if you want to follow the development pipeline, it is completely possible from the very early design phase to the production version, everything built in Incari. I would like to give you an overview about the streamlined workflow and the approach and how we think the streamlined workflow is a very good one, especially for the HMI production. So as Incari Studio, as you can see it here, this is the authoring tool. This is the tool where you can create your HMIs depending on the assets you require, depending on the HMI project you're working on. So you can add 2D data, you can add 3D data, you can add interactive content which has already been created externally via HTML, for example. You can add a variety of scripting and programming languages in order to get the desired HMI project or the desired HMI outcome directly out of Incari Studio. So on the one hand, you import everything in Incari, you enrich it with logic, so and sort of you program it, and then to Incari Player. Incari Player is the runtime system which runs on the embedded boards for target systems, and Incari Player is just a very slim and very little runtime application which directly runs as a process on the embedded boards. And you can use multi-output devices such as cars, such as white goods, or even VR installations. So we say every embedded board which is capable of running Incari Player has the possibility to run Incari HMI projects. And as you can see in between Incari Studio and Incari Player, we've got Incari Simulator. Incari Simulator is actually a live design purpose tool which is integrated in between the authoring tool, Incari Studio, and Incari Player, where you iteratively or interactively can change the design, you can change color, you can change the position on the screens, which allows you to rapidly have design decisions rather than doing presentations on a PowerPoint basis. So I will talk about this a little bit later, but this is how we think the streamlined workflow for the HMI production is set on Incari. This is Incari Studio, how it looks like. I will later on also show you a little live demo, but here, this is just the overview. As you can see, it's just a very, very straightforward application. You got a scene tree where you can see all your assets. You got on the upper middle, this is the rendering engine where you can see, in this case, an instrument cluster running, and the hard component is the logic editor. So I believe some of you already know this visual coding approach. So we actively decided to go down the approach of visual programming based on nodes, based on a huge toolbox with a variety of, I think, more than 220 nodes are available right now in Incari, that even a person who has non-coding skills is able to develop their own logic from the very early design phase. So for example, even a UX designer, I would say, is able to create a clock logic very easily with a given toolbox, the tool sets based on Incari. So I will show you a little bit later, but this is how Incari looks like. Very straightforward, specifically designed for. We want to make sure that we're able to connect from the line phase, such as technologies, feedback gesture control technologies, and up to futuristic technologies such as mid-air haptics or and also stereoscopic display, that you're not only really mean to create an HMI system for with all the 5 sensors, and having those kind of interfaces, it allows you even on the design phase to play around with those kind of technology bricks, and enables you to think much more ahead than just the visual component of it. So in 2017, actually, well, we had the idea to develop Incari. We did so. We started to develop our rendering engine. And in 2017, we also successfully integrated our first prototype into a pre-series car. This is German car brand, Isdera, it's called. And we were integrating our rendering engine, our Incari player. And with this project, we set the basis for all upcoming future features for Incari Studio, such as canvas integration, Bluetooth support, multi-screen support, up to augmented reality support. I just want to show you how it looks like. So just turn the car on, start sequence starts, the welcome animation boots up. So we have proven with this proof of concept that Incari is now actually able to run in a productive environment and a productive car. This car has been presented in 2017 at the Shanghai Auto Show, and I think it is going to be produced in a small series in the upcoming years. Also, I would like to mention Incari Simulator, Incari Sim. This is what I've mentioned earlier, is the, let's say, the interactive design finding tool. While driving, so what we've done is we've recreated with a game engine the inner city of Paris. And while you're driving through the city, you're able to connect Incari live to the system. So you get all the live values such as speed from the game engine into Incari. And while getting those information, you're able to modify the widgets, to change them in color, to change them in position. So just in order to identify what could be potential issues, is a button too small or too big? Is the color disturbing? And just want to give you a little overview about this. Video has been recorded here just to see how it actually works, the concept. Even when the video is quite old, but the concept is still the same. So for example, you want to apply a new style sheet, a new color, and everything changes from red to green, or in this case, from green to red. Or you move it to the windscreen, for example, and while doing that interactively, you can manipulate it. You can make the widget bigger. You can move it to the left, to the right, just to identify if it fits perfectly in your driving environment. I said this is quite an old video, but the concepts of Incari in this Incari simulator is still the same. So yeah, play around with the speed widget, and 11 kilometers an hour coming directly from the game engine. I think for the presentation, for the theoretical part, I would like to explain a little bit to you on a little live session how Incari actually works. So for this, I'm going to switch to my system here. And let me log in. So right now, Incari Studio works on Windows. So the authoring tool works on Windows. The output of it, just for your information, is also working on Windows-based systems, and it can also work on Linux-based systems, depending on the target hardware. So you can compile them to target. Okay, so just to give you a little overview, this is Incari Studio, how it looks like. So it's a very classic approach. We got a 2D and a 3D view, as you can see. So we have a native 3D environment. You're free to move around, similar to what you might know from 3D modeling tools such as Maya, 3ds Max, or Blender. Same approach. So we have a native 3D environment, and we got the 2D view. This is actually the view of the render view, how it actually looks on the cluster. So let me simply just, before I start to explain the modules, just press play. So what it does now, it gathers all the information and from all the widgets, and Incari Studio and Incari Player starts up. So this is the runtime, as you can see. And here's some logic applied to it. So we're right now in the parking position. We got the handbrake turned on and no gear selected and at 0 kilometers an hour. Incari Studio is an event-driven system, which means it reacts on events coming from several external or internal events. Such in this case, for this demo purposes, we have key presses defined. So I press space. This is the event to get everything up and running, to ignite the sequence. So as you can see, we're now in neutral mode. The handbrake is off. I press the up arrow key, and now we start to play and we drive. I leave the key, and then I recuperate. As you can see, we've developed here some a hybrid mode. I can turn on indicators, left and right indicators. I can turn on the telltales and off. So everything is being now put on key presses, which represents a key. Okay, even here, the odometer and the time is directly coming from the system time. As you can see now, it's in Berlin, it's 3 p.m. And the car already drove 3,628 kilometers. So how to do this? So let me explain to you. First of all, you need to set up the project. So in this case, I'm just talking about this instrument cluster here, but in general, when we're talking about an HMI project, we make a differentiation between a screen and a scene. The screen is the physical representation of the actual screen in your car, which means here screen number 0 is the cluster. And as you can see, on the right-hand side, we got the attribute editor. You can set some resolution and size, some OpenGL settings, near clip, far clip, some 3D settings. If I had, for example, another screen as a center console, I could go right-click, create screen, give it a name. For example, this screen would be my infotainment screen. Infotainment. There we go. And I could give it a different resolution. I would say this one would be maybe 1280 times 480, which is a common resolution. And then I will add a scene. A scene, every screen contains scenes. A scene is actually a functionality, a certain functionality. In this case, for my infotainment system, I would like to create telephone, navigation, radio, media player. So just scene, as you can see, give it a name, call it media. And it instantly opens up an empty stage for me, an empty 3D space. And here I got the bounds of my 2D representation. And so while creating new scenes, for example, phone, just to give an example how to create the structure, as you can see, now I got 3 tabs open. and each tab represents a scene of a screen. Okay, so but for this example, I'm just leaving it for the instrument cluster to give you the example. Okay, here we go. So now I switch to my scene outliner. The scene outliner represents actually every asset which has been imported to the scene. So we got some side meters, we've got groups, as you can see. Everything is well organized, well prepared, and as you can see, we have different icons, and those icons represent different asset types. Just right-click, go create. I don't explain them, but as you can see, we support a variety of asset types which are required for an HMI system, such as, let's say, texts, web sprites, 3D meshes, lists, image sequences, things you can, things you require for generating an HMI on a visual basis. So, and every asset can then easily be manipulated. As you can see here, I can type in by some placeholder text. I have some transformation textified. So every attribute of every sprite depends on the asset type, and I can play around with them. Okay, so just to give you a little example, and as I've said, even a guy who is not say a person who's not able to program is able to create a simple logic in Incari with a non-coding approach. And so let me explain to you, for example, I would need a logic which says if I exceed a speed of 50 kilometers an hour, please change the text to a red color, because that indicates, okay, I'm going too fast in the city, so I need to throttle down. So how to achieve this? So let me open this up. As you can see, as I've mentioned before, Incari has the logic editor, and this is what I would like to explain to you right now. So let me undock this. Let me unlock this. All right. So the logic editor is actually a big content pane, which is empty usually. But here you have the freedom to create your own logic. So let me move in. And as you can see, it contains of visual nodes which are connected to each other. So in the logic editor, we do have our toolbox, which are the standard functionalities which Incari offers by default. So we already have, as said in the beginning, about 200 to 220 nodes. I'm not sure how many, but there are many. And as you can see, they're categorized actions. So you can do delays, you can rotate and scale actions. We've got communication nodes, CAN bus, HTTP and MQTT. We got Incari specific nodes, mathematical operations, string operations. I'm not going into detail here, but we got a variety of them and a huge variety. So as I've said, I'll create a logic which allows me to manipulate this text here. So as I've said, we are an event-based event system. So I go to, and I would like to create an event based on the current of a variable, which is called speed. So as you can see here, we have some variables, and I will search for a variable which is called speed. This is my speed variable, okay, which has been used 4 times in my project, and I will drag it here. And when I drag it to this big screen here, it will ask me what shall I do with the variable? Should I read the value, or should I set the value, or should I create an event when the value is created and the value is set the first time? In this case, I would like to create an event when the value has been changed. Okay, so my change event. This is the value. Next thing be with the right click to access also context menu. We type like to compare the current value with another value. This is the, and now I can connect them. Value A, which is my speed value, with a value B, like here. This numerical value would be 50. Okay, so the logic would be do something when value A compares B is greater or equal then it will be C. C is Boolean, it's a true or false value. As you can see, all our data types, they have a colored representation. So Incari in this case is also type safe. All right, so I said I would like to have Incari is greater, then A is greater B, then it will be true, else it will be false. If then else clause, so I would need to have a branch. As you can see here, this is the branch. It requires a red data input, which means this is the true or false. Now here it comes. The white cable I'm connecting here through the nodes, this is the pulse. All the nodes which are connected to this white cable, the nodes are being processed. If they're not connected, even when the data is going through, they are not processed. So I'm just connecting them. Dynamically switch between branch. I have the is greater, and then I'm just making the decision on true. Please change something, and now I need to have the color information, and the property I'm searching for is set tint. Here we go. Because tint is a property of the speed text. So let me grab this text here. So this is the gear text. I need to search on my speed gauge, my speed text. So this is my entity speed text, and it requires an object ID. I'm going to grab it from my scene outliner and drop it to my logic editor. Now automatically generates the reference to my speed text in the scene outliner. So let me connect the object here. And then I need to go for a color. So this object requires a color. This color value is being connected here. And then I give it a value. The value would be then, in this case, red, like so. Okay. So my first logic is done. The onTrue clause is done, which means if the value of the speed is exceeding 50, then the tint of this object is red. Else, on false, duplicate. If it's below, then please don't do anything. So I turn it back into white, and white means no tinting at all. And this is basically it. So this little logic here defines now my behavior. Pan and group it. Okay, call it speed red logic. So if it works. So when I press play, okay, here we go. So again, I press ignition sequence started, and I press the up key. So when now, let's take a look at the numbers perfectly. I leave it. It gets back. Oh, there was some chopping. So when I'm below 50, everything stays white. When I exceed 50, it gets red. So as you can see here, it works quite well. Logic applied. Yeah, no coding at all. At the same time, also, for example, when I would be the guy in charge of developing a logic for the HMI, and I would like to hand it over to somebody else in the team who really does not have any idea about logic, you could also select the logic brand and can export it. So we have sort of this blueprint approach, which you might be familiar with. So we can just easily export it into, give it a name, red logic, and put it maybe on the desktop. I already did some, and then it's exported. So let me delete it. I don't need this logic. And imagine I would work on a new project and I need exactly this project logic. I could import this and say red logic, and here we go. So since everything has been represented in a human readable format while working, it is very easy to im and export those kind of functionalities. Okay, This is from the component. This is from the logic component wise. Also, what else? Let me go back. Logic again, because this is also very important. I mean, now I'm working. So I'm working on an event which is being defined by a variable when the speed is changed. But what is if I had now a real canvas integration? So because then I don't really need this variable. I would like to use a real canvas value, a real canvas information. How to do it? So I go to my project settings, and my project settings I can define several values and functionalities for certain stuff. And as you can see, we got an entry called can. We can define the CAN bus interface name, the baud rate, the performance, the speed of it. And I can also define the DBC file. The DBC file is actually, I would say, the database representation, the description of messages and signal of a specified CAN bus integration. So I'm just opening this up. I got a DBC file here, which comes from the engineering team. And now, since I'm using this DBC now, I have access to this DBC. How to do it? I go to my toolbox, and I know that it requires some sort of a communication. Because CAN bus is communication, it will be part of my communication branch here, and I open up CAN. And it's an event, which is called on CAN packet received, which means if on the CAN bus a packet is received, do something for me. Okay, as you can see now, it requires something that it has a red outline, so it indicates, okay, there is still something I need to set up. And here, as you can see, the message name, according to the DBC file, I have access to the messages. Okay, and in this case, I would like to call, this is German, ist die Geschwindigkeit, which means speed. I click on it, and it instantly gives me the appropriate values. So the speed of the vehicle is a float, which is this purple indicator. And I got also an alive is alive, and a CRC, a control, if the speed is okay. So instead of using the variable, I could easily replace this with this. So which means the value now comes directly from the CAN. So if I had now a CAN bus device up and running, gives me this message, I could automatically use it, and I have direct access to it. Same with other protocols. Talking of them, if I had no CAN bus available, I could also use HTTP. I could also use MQTT, which is actually MQTT is more for the IoT world, but basically a lot of times being used in the UX design environment. In the end, it delivers sort of the similar functionality to CAN bus. So what we've done in projects, for example, is to develop everything on MQTT messages, and then in the end, building a branch to switch between CAN or MQTT, depending on the purpose, on the use case. What else? Since we're having a native 3D environment, let me close this quickly. Okay, since we're working in a 3D environment, we also have the possibility to open native 3D files just by drag and drop them from the asset manager. And as you can see, we got now a 3D model in this space. So and since we're working in 3D space natively, I'm able to move it around freely. Let me rotate it by 90 degrees. And as you can see, this is a 3D model. There we go. And of course, we do support shading as well. So this is currently now grayscaled. But if I would like to have access through 3D models, I can also shade them. How to do it? As you can see, this is the reference to the mesh, to the FBX file, and here also we have the reference to the material. So when I double click on it, when I click on it, it opens up my quick selector, and I already got an Incari material, which is called car paint. That looks quite awkward to me, as it still misses something. So let me double click on it, and it automatically opens up the material editor. And the material editor have the possibility to change the material behavior. In this case, we've got a car paint. We got also a shadeless material, which is just the color information. We've got a glass material, which represents some transparency effects, and a default PBR model. I think this is very important. We are doing the PBR workflow, which means it's the physically based rendering approach, which means for lighting information, for lighting purposes, it requires a 32-bit environment, in this case an HDR map. So I'm gonna just click on it. I'd like to load it. And we got here, where is it? Here we go. 2K should be okay for us. It's a studio environment. And now I've got here my studio HDR. I click on save and instantly now the real shading appears. So I'm gonna go closer. So the same thing I can do for my windows, the same thing I can do for my tires, for my rims. Let's go for some rims. So I'm going to create I'll just use this one here, maybe a new material. Open this new material up and switch it to default font material, default PBR material with the same environment texture. Here we go. And then play around a little bit with the values. For example, the color, make it a little bit more dark. I can also, the specularity is okay. You can play with the roughness a bit, maybe like this, a little bit darker. There we go, save. Okay, and for those components now, when I go closer, yeah, very nice. I got now my dark rims. Okay, so this is for shading and 3D model capabilities. Also, what we have in Incari is an animation editor. So let me explain you a bit how the animation editor works. So on the one hand, you could do animation programmatically via the logic editor. I've explained already to you in the toolbox, we've got already translations, crossfade, fade. We also got screen effects. You can fade from between, you can move them, you move to left, move to right. But you can also do static animations based on a keyframe animation. How to do it? I go and open up the animation editor. So move it up a bit. And let me create a new animation. Give it a name. So create an animation and call it car animation. Create. And as you can see, we've got a standard timeline, a keyframe-based timeline with a default animation block. And I would like to move my car from left to right, just an easy one. So I grab my whole car, add it here, and turn on the preview mode. No, just first turn the preview mode on, select my car, and as you can see, I've got now my position, rotation, scale applied, visible, and now I can turn on my keyframe. So I've added a keyframe at frame 0, move it along here a bit, and just move my car a bit. So basically straightforward. Also hit apply, and I instantly get a key. So let me save this animation and give the animation block a name. Call it car move, because later in time, and hit save. And now via the logic editor, I have the possibility to execute this animation. Okay, so how to do it? I go to my cluster logic. This is the nice one. I leave it here. And as a second one, for example, I would like to choose a new event, a key press event. So I'm searching for key press. When I hit key number 1, no, in this case, when I hit the key E, I would like to play the animation. Play animation. And this animation is here, my car animation, and has the car move. All right, so let's see if that works. Press play again. So it takes a little bit longer as we have now 3D components inside, but it should work. So meanwhile, while exporting, as you can see here, the indicator now it does something. I'm still able to do some stuff here. So while it's exporting, I would like to add maybe, I'm just give it 1 more second or 2 more seconds. Okay. Well, I don't want you guys wait too long for this. Sorry, but usually it takes longer. As we have quite a limited time, I just would like to skip it. But you can be sure it definitely works, but I don't want to waste too much time here for compiling just stuff. All right. Maybe also what is very, very interesting is that we also support websites, native web elements directly in the 3D engine, which allows you to already play existing websites which you already have created in some projects for HMI topics. I know that there's a lot of HTML being used. So you have the possibility to add a local file which you already created. So, but also you are able to call remote URLs. So let me call YouTube, for example. And as you can see, it should open up instantly here. Here we go. And it's actually, yeah, a 3D element. I can move it freely around. It is already accessible. So when I press play and it compiles, I have the possibility to directly access it here. Okay, yeah, I agree. So imagine you could have started using a media player, for example, based on websites. Let's go for some deep house music. So click on it and you're instantly able to play around. So yeah, if you can use the embedded codes, it should work perfectly. Full screen mode, yeah, skip ads, and then we can just start playing music. So it's fully functional web browser supporting also WebGL in an OpenGL, what I called WebGL engine. It will be represented there as well. Very important, for example, if you used map data, such as from maybe in here, Mapbox, whatever is available, Google Maps, Apple Maps, and so on and so on. All right. Also, this is important that you can directly communicate via the Incari logic with the web resource. You can just you go to the logic editor, and you have the possibility to go on the web resource, which is here, or web. You can call a JavaScript function. So all JavaScript functions which are exposed to the window are directly accessible via the Incari logic. So you could either get some information, for example, if you had a speed meter developed already in JavaScript or particle systems, you can have direct access to it via the call JavaScript function inside Incari. And I think this is a very good way to control already existing projects. Just rather it is better to integrate them rather to recreate them from scratch. And I think this is the most important topic here, that with this technology, you're able to reuse existing data already, to merge them together on one hub, which is able to drive the different components here. So what I was showing here is just the version 2.0. 2.1 is also getting additional functions and features, of course. So we will have a native vector rendering engine integrated. We also then support native compiled C++ logic, but I think this is also part of the upcoming Q&A session, and you can ask specific questions about this. We do support, as said, style sheets. We support web sprites. We support image formats, a variety of the yeah. What can I say? Very compelling, very good, and very easy to learn HMI development platform. So last but not least, maybe this is something I could show you quickly, just to open this up. Import a project. Go to projects. And here we go. Yeah, okay. So import, let me close the player quickly. import demo projects, and then we go for the 3D. I think because the Incari player was running in the background. Now here we go. Should work now. Okay. I think this is a little bit delay here, but it's okay. There we go. Okay, very nice. Yeah, just wanted to show you the 3D capabilities of Incari Studio here. So this is a full 3D environment where you have access, a full shaded model where you can play around with it. Yeah. Okay. So I think from this perspective, I'm done with my presentations.
Wonderful stuff. Thank you so much, Alex, for that very detailed presentation. You'll be very pleased to know that we got a lot of questions from the audience there. So obviously you've stoked some interest. Start with a very basic one. What is the size of the player in megabytes?
The empty player, you mean?
Mm-hmm.
Yeah. Mm-hmm. Abdallah, can you answer this question for me?
Yeah, I should say that Abdallah is here as well to take questions, who is the Director of Engineering. But Abdallah, please take the floor.
Yeah, sure. Due to the modularity of Incari, of course, if the more modules you load, like CAN or the 3D system or transition system, then you get a bigger player, of course, and depending on your projects. But the bare minimum, it's about 3 megabytes.
Wonderful. Thanks very much. And is it possible to create custom notes in the visual programming editor?
Yeah, we already had our thoughts about this, and we want to release soon an SDK where people can go and create their own plugins and of course nodes for the node-based system, because we have at the moment 210 I think nodes, but we cannot think about everything that the people would like to implement. So yeah, sure, you will need to use, of course, you need a basic knowledge of C++, but yeah, you can create your own nodes.
Wonderful, thanks. Alex, did you have anything to add there, or shall I can move on? There's quite a few questions to get through, but I can pause.
Yeah, no, don't. Just move on.
That's okay.
Just move on.
All right, wonderful. Thanks. Okay, so another question from the audience. How do you get the variables into the logic engine so that they are selectable from pull-down menus?
Those variables. Yeah, please go on, Alex.
No, I said just, well, the variables, you can just easily create them inside the logic. So actually, our state machine we're offering is our variables. So all the states are represented through our variable concept. And you can just easily create them. A variable can have a state, can have a certain data type, and then you can work with it as described already, as an event, or just as a getter, or just as a setter.
Wonderful, thanks. Now another audience question: when would you include a node in a logic editor that is not processed?
It is already there. Okay, maybe I forgot to mention this. So in the logic editor, you have the option to say enable or disable. Even when it's connected to the pulse, you can say, please do not process this specific node.
Great stuff. Okay. Okay, another audience question: can multiple people work on the same project at the same time? Is there a merging feature?
Yes, there is actually, because the system, while you're working in Incari Studio, every file you create is in ASCII, so human readable. So, and we use Git to commit the project. So yes, you can actually work with multiple team members on the same project and merge different parts of the project later on in the same Incari session then. Yeah.
Wonderful. Thanks, Abdullah. Okay. Another question. Am I able to write my own custom open GL shader?
In the current version, it's not exposed, but I don't see any problems to integrate like a custom material where you can write your own fragment shader and add it to the pipeline. Yeah,
it's already on the list.
Yeah,
it's on the list.
Okay.
Yeah.
I'm guessing sessions like this do provide you with a kind of a kind of bits and pieces to add to your list, which is I imagine ever growing. Another audience question actually: does the animation editor support easing curves?
Yes, it does. So you can set flats, you can set constant, or you can set Bezier curves in order to simulate ease in, ease out.
Okay. Actually, as we're chatting, we've got more questions coming in here. So I'm just going to try and keep half an eye on them. But is there a native particle system? Is another audience question.
Not yet. It's also on the list to have a native OpenGL particle system, but through a web API, you could use a JavaScript particle system already, fully functional. So we have projects where we used green socks as a basis for generating fancy particles coming out, visualizing an airflow, and you could via drag and drop or while swiping over an area, could manipulate the color and the speed of those variables, of those particles.
Wonderful stuff. Gosh, they're coming in thick and fast, the questions. What about importing localization tables to translate the HMI into different languages? That's another one from Benedict in the audience.
Yeah, we are currently working on the localization editor. So yes, where you will have a model for each language and have a key value pair of language and key and translation. Yes, so we're working on it.
Great stuff. And what about real-time reflections and shadows?
Well, we do support classic OpenGL shadows, spotlight point, directional light shadow maps. Reflections are not supported yet, but as I said, those are quite some OpenGL features which could be easily implemented over the time. I need to mention we're quite on the market, so we were just we're working constantly on adding new features and functionalities to the OpenGL engine.
No problem. Another question from the audience: what's the startup time for an empty project?
The startup time for an empty project, well, seconds, not even seconds, 1 second.
Yeah.
I haven't tested it. I think
if you mean the player startup time or the studio startup time?
I think they mentioned the player startup time.
Yeah, it's some milliseconds. When it's empty, then there is nothing to do.
Yeah, it's 10 milliseconds. It's instantly there.
Yeah, I think we could say probably instantly in that case. Are there any options for performance monitoring? Another question from the audience.
Yeah, we have a profiler built in. Currently not exposed to the UI, but yes, if you know how to do it via the nodes. At the moment, it's only accessible via the logic, but we are working on building a module like in Incari Studio where you can monitor your performance. Yes, so there is a profiler integrated into it.
Wonderful, thanks, Abdullah. Another audience question. Sorry if I'm jamming through these. I hope, guys, that everyone's getting what they need from the answers, but I'm sure they are. Here's another one. Is there an interpolator available for animation players?
An interpolator?
Mm-hmm.
Yes, there is a node which is called interpolate, and you can define the interpolation node, constant, linear, Bezier, ease in, ease out. So yes, to answer the correct, there is an interpolate node in the logic.
Lovely. Okay, another one. Here we go. Is there a roadmap for Incari?
Yes, there is. Midterm now exceed the amount of webinar, but I would be more than happy to share the roadmap individually then.
Okay, wonderful. Can people get in touch with you directly then, Alex, if they want to sort of inquire further? Wonderful stuff. Yes. Can you deploy a release to work in any environment, OS/OS?
For the prayer, we support currently a lot of different OSs, yes. So you can deploy it to Windows, you can deploy it to Linux at the moment, on different also processor architecture, so ARM32, ARM64, on embedded boards. So yes, the player is really done. So it's built for this deployment on very custom OS, like also Yocto and like a lot of different OSs. On the Studio side, we are working now to port Studio to a Mac version. So we currently support Windows and Linux, but the Mac version is coming in the next as a next step.
Wonderful, thanks, Abdallah. There's another question here. Does Incari support theming?
Theming. Well, you could, yeah, theming. I guess what the question's after is if you could easily change, let's say, a color theme to red and green or blue and whatever. This is actually being done through the logic. So if you set up appropriately your theming, your definitions, your color palettes, your tables, and you change the color palette and the references are changing as well accordingly, yes, of course you can.
Great stuff. Is LOD and MIP maps implemented?
MIP maps, yes. LOD, not at the moment.
Do you have any plans, Abdallah, or is
yeah, sure. I mean, we have a very huge roadmap, of course.
Yeah.
I'm sure. Okay, wonderful. Well, I've got a few other questions here I can ask you, but just another note from one of the audience just saying thank you very much for answering the questions. That was sort of rapid fire thing. I've got a question for you. What type of assets can one import in Incari?
Alex, will you answer?
Yeah, sure. So what kind of asset types can be imported into Incari? What's the question? Well, any image type you can imagine, from 8 bits to 32 bits, 3D polygonal data. So FBX, as you saw, OBJ is the commonly supported format. Vector formats such as SVG, website components, so pure HTML and JavaScript. Yeah, and way more. We have a detailed list about the supported file formats on the webpage.
Good show. Another audience question has just popped in actually while we're talking. Is mesh morphing possible in Incari Studio?
No.
And not at the moment.
No, the issue is it's just an easy answer. Mesh morphing is nice, but it requires a lot of computation power on the GPU, and embedded systems are quite not so powerful as a regular PC. So you need to. There are other ways how to fake this kind of mesh morphs.
Wonderful, thank you. And another audience question: does it support HoloLens? Yes,
well, we do support stereo rendering. So if we have the HoloLens applied to it, of course. So I think that the basis is stereo rendering. Since we do support native, let's say, autostereoscopic displays and VR helmets, I'm pretty sure that we support this as well. It just requires some minor adoptions, I would say.
Wonderful, guys. I've just clocked the time, if that's no pun intended, but we're approaching the end of our allocated hour. I'd just like to thank you so much for the presentation and for coming on and telling a CDN audience about it. I will say just to everyone watching, there's going to be a recording of the presentation that Alex has done, and Abdallah and Alex answering questions. That's going to be available on the CDN website, so you can revisit that in, I suspect, about 24 hours it will be live, but we'll try and make it sooner. But you know, that's what I'm going to say, and I'll stick with that for the time being. So, just to everyone who contributed and asked some questions, thanks so much for attending, and to Alex and Adela, thank you so much for coming on, showing us your software and engaging with the readership of CDN. Thank you, guys.
Thank you.
Thank you very much. Thank you. Bye-bye.
Bye-bye.
Bye.
See you soon.